Okay, now consider the following example. You have a program and you've broken it up into three chunks. The input chunk, the calculation chunk, and the output chunk, and perhaps also the main as well. The input chunk might be something like this. Please enter three numbers. The calculation chunk might be to calculate the average of those three numbers, and the output chunk might be to print out the average. Fair enough? Pretty simple. So obviously you're going to have three, let's call them integers, x, y, and z, and another integer, or perhaps a float called average. The question is, where do those variables get declared? Do you declare them inside main? Or do you declare them somewhere else? Do you declare them perhaps when they're first used? Well, you'll find that, I'm going to show you an example of this in a moment, but you'll find that if you create a variable x or y or z or whatever inside main, the only place you can use it is inside main. You can't use it inside your input and output and calculation functions. You just simply can't access it. If you refer to it, the compiler will give you an error message saying, sorry, I don't know what variable you're talking about. I've never heard of such a variable. And you might think, well, hang on, it's in main, and main is the granddaddy of all functions, therefore, if it's declared in main, it can be referenced from anywhere. Well, that's not true. So there is a solution to that. It's not a very pretty solution. I don't like global variables very much, but global variables will solve this problem. Global variables are a stepping stone towards function parameters. So if you do know where we're going with this, please just bear with me. We've got to go the long way. Global variables. A global variable is a variable that can be accessed by more than one function. In fact, if it can be accessed by even two functions, then it can be accessed by every single function. Okay. Compare and contrast that with non-global variables, known as local or stack variables. They can only be referenced by the function they are declared in. Every variable we have used so far, every single one has been a local variable or a stack variable. Every single one. We have never seen a global variable before. And I'm not really keen on introducing them now because I don't like them very much. They do have their uses from time to time, but I try and minimize them as much as I can. I really don't like global variables very much. And you'll see why when we start to use them a bit. What you'll discover is if you start making a practice of making everything global, then you might have something called count used in one function, and you might have another thing called count used in another function, and you might be trying to use them for two different purposes. And however, they're both called count, so they're actually the same variable, and so they'll interfere with each other, and your program will have all sorts of trouble. So it's best to keep variables as local as possible. However, we'll talk about that later. Global variables, you should know this just as a thing to know about the language. The compiler will automatically initialize every global variable to 0 as they first get run. Now it's obvious what that means for ints and floats. They'll just get initialized to 0. What does it mean for arrays? Well, for arrays, every single element will get initialized to 0, and for strings, that means that every single element will be the null character. That's just to start with. You can obviously set it to whatever you like as soon as the program actually gets going. So, global variables. Let's go and have a look at a global variable. I'll pose the average problem to myself and then try and solve it, and I'll walk you through the process of me solving it. Let's have a look at that. Okay, here's a program that I've called average.c in the chapter 10 folder. It's just a main at the moment. It's just, as you can see, it's pretty straightforward. Just enter three numbers and we work out the average sticking in a float. I make sure that the average is actually a float by dividing it by 3.0. I could just as easily have cast that sum there to a float by doing this, which is in fact what I will do. It's a little bit more obvious, more explicit what's actually going on. Okay, so that obviously works, but I decide to myself that I don't like this program because it's not broken down into nice discrete chunks. So I'd like to have all of this as my input function. I'd like to have that as my calculation function, and I'd like to have that as my output function. Alright, let's do that. Let's create those curly brackets around that. We'll give it a name. We'll call it input. Okay, and obviously it's just about done, except I can't have it sitting inside main because that would be wrong. So I cut it from there and I paste it there. Now I give this one a name as well. I'll call this one average. Might as well just call. You can actually call a function the same name as the actual C file itself. So because that's what it does. It calculates the average. So I'll cut that from there and put that there, and I'll cut that from there. And I'll put that there. It's no good just sitting that by itself outside there like that. I have to put it, every line of code that actually does something must live inside a function. I could actually compile that and it would not compile. It simply wouldn't compile. It would say that there's not supposed to be a printf there or whatever it would say. It would give me some error message. And I'll call that output because that's what it does. It produces the output. Okay, so it looks like I'm pretty much done, yeah? Shall I run it? Shall I compile and run? Let's see. Ooh, 9 errors. I've got a little error going on here, sorry. Oh, well, okay. This is exactly what I thought would happen, yes. num1 undeclared, right here. Okay, right there. num1 is undeclared. Interesting. Now num1 is declared, it's right here, but it's inside main, which means that the only place it can ever be actually visible, the only place it can ever be referred to, or used, or added to, or its contents inquired of, or anything like that, is inside the main function. In other words, you can't refer to it inside the input function. You think to yourself, oh, that's pretty straightforward, I'll just copy and paste it then. I'll just copy that, and I'll put it up here. Surely that will solve the problem. And I might have to do the same here as well, so I'll put it there, and I obviously have to do the same thing with average. So I'll copy that and I'll put it there because I'm going to need it there and I'm going to need it there as well. And then I won't need it here. Good, let's try that. Compile. Oh, no errors. Excellent. So it must be on the right track. Run the project. It's not doing anything. Not doing anything at all. So, what have I done wrong? Well, I've done exactly the same thing as I did in the first example that I showed you in the last module. I didn't actually call the functions themselves at all. So let's do that. I need to do input. Don't forget the semicolon on the end there. I need to do average. That's the name of the second function. And then I need to do output. Okay, so now that should work. Let's try that. No errors, and run. Please, oh, okay, now we're off and running. 12, 23, 34, the average is 0. Still there's something wrong. Still there is something wrong. Can you see what the answer might be? Well, the answer has to do with this. Here we enter 3 numbers, num1, num2, and num3. So we fill up these 3 variables with the numbers from the keyboard. The next thing that happens is we end up in this function. 3 brand new variables are created. Those 3, num1, num2, num3, have actually got nothing to do with those 3. Nothing at all. They're 3 brand new variables. And then we work out the average of them. And so what are they going to be set to? Well, they're just going to be set to random numbers. Remember, they're uninitialized. They have not been initialized. Initialization happened up here, but it happened to a completely different set of variables. So these 3 are uninitialized. And average will be the average of those 3 random numbers. Then we come down to here. Do we print out that random of that average of the random numbers? No. We actually print out a brand new random number, because all we do is we create a brand new variable which is never initialized, and we print out its value, which just in this case happened to be 0. That was just a fluke, I suppose. So clearly we've got something wrong here. We cannot declare our variables in this manner. So what we do instead is we take them outside of the functions altogether. We declare them out here. Oops. Okay, now that is a valid declaration. I'll come back to that in a second because I need the float one as well. Delete all that code, and I can delete that code. And I'll put the float there as well. Okay. I have now declared 4 global variables. They're global in the sense that their values can be accessed from any function in the entire program. Remember just a moment ago I said that you could not do this. Copy, paste. I said you couldn't do that. That line of code I said was not valid. And it's not valid. It generates code. This is actually a code generation line. It causes the program to do something. This is not a code generation line of code. The program does not do anything when it encounters those two lines of code. All it does is it sets aside a definition. It knows what num1, num2, and num3 actually are. Lines of code that actually do something, like they print something out or call a function or whatever, they have to be inside a function. But declarations of variables do not have to be inside functions. We only prefer them to be inside functions. We don't prefer them to be outside functions like this because it's, well, it's stylistically bad, but we'll examine that more later on in the course as to why that's a recommended way of approaching variables. Anyway, so we've got some global variables now. Let's see if that actually fixed the problem and our program works. Oh, no, we've still got some errors. Average redeclared as different kind of symbol. What's going on there? Well, I didn't think of this would happen. This is a new one on me, but it's actually correct. There is a function called average, and there is a variable called average. So it's clearly wrong. One of them has to go. One of them has to have their names changed. So I'll change the name of the variable. I'll call that average, like that. AVE, AVE, and AVE. Okay. Notice that the main doesn't refer to any variables at all. Interesting. The variables are only referred to by the three functions. Okay, let's try that again. No errors this time. Run the project, enter the first number, 12, 34, 56. The average is 34. Believe it? Well, it is, believe it or not. Okay, so now it is working. That is, I guess, the classic example of how global variables can be used. You can initialize them in one function, involve them in a calculation in another function, and use them in a third function if you need to. They can be used anywhere. I could even refer to either num1, num2, num3, or av down here. It doesn't matter. If they're global variables, they can be used in any individual function. Okay, so that's global variables. I'm now going to move on, and I'm going to show you functions that are more sophisticated than the three functions that we've seen so far. And the sophistication will be such that we won't need global variables anymore. We won't need them. Occasionally we still use them, but we try and avoid them wherever possible.